Hello, and welcome to the December 2025 edition of Azure Database for MySQL webinar. I'm Saurabh Kirtani, a Senior Product Manager with Microsoft Azure, and I'll be your host for today. We'll be covering a series of exciting updates that we have unveiled at Microsoft Ignite a couple of weeks ago, which will help you build more smarter and resilient apps. Today, we have an exciting agenda in front of us where we'll have Sudheesh talking about enhancing MySQL resilience. We'll be talking about a number of features like reader endpoint preview, dedicated SLB failovers, rename server, and case-insensitive tables. Next, I'll come back and I'll be joined by Heena, who's a software engineer at Microsoft, where we'll talk about building serverless event-driven applications at scale. And then I'll give you a quick recap of all the other announcements that we have made for Azure Database for MySQL. And with that, I'd like to invite Sudheesh on the stage, who's going to be talking about a number of updates that we unveiled.
Hey, thank
Hi,
you, Saurabh.
Sudheesh. Yeah, please go ahead.
Yeah, and good. Let me start with a good evening, good morning, or good afternoon, depending upon the time zone you guys are in. So I will take you through few of the good Ignite announcements we had with few private preview announcements as well on why we are releasing it, what is the purpose of it, how can you enroll, etc., and also on the feature details with some demo. Let's get into the agenda. Can we move to the next slide? Yeah. The one of the important feature which brought into the private preview this Ignite was reader endpoint private preview. Now, what was the goals when we decided on this was we wanted a unique endpoint when we had more number of replicas. So like you see in this architectural diagram, if when you have more number of replicas, currently the biggest trouble the customers had was they need to actually change the connection string when they wanted to move from one replica to another replica, and the connections are all directly beat to that replica connections, and the read workload management was very difficult when you had more than one replicas. The You need to actually target every configuration strings, and you need to control in short at an application level. But here what we are doing is we are bringing a endpoint where you can target your reads to, and when you target the reads, what would actually happen is the reader endpoint will decide, depending upon the routing logic which you use, whether you need to select replica 1, replica 2, or replica 3 based upon a DNS name splitting. It also takes into consideration the health of the replicas. Like suppose if there is an replica 2 is unavailable, it doesn't participate. So the application side never has to be bothered about uh, which reader or which replica that my query is going through. And it is a connection based routing. So whenever a connection request is being made, the response the reader endpoint give would be the to the connection request would be the name of the replica server to which it can connect and poll it. We are also bringing in health monitoring using replication lag, because replication lag is an indicator of should I do a read query on a particular replica or not into the health monitoring here, where we customers can go ahead and select a permissible lag, and then they can treat that anything beyond that particular lag is not considered healthy to me. So make sure that particular replica doesn't participate. When the replication comes below it, it becomes a part of the replica. I mean the list of replicas or the replica nodes which can participate in the connection routing. So this way you will be able to manage the connection string. Can we move on to the next slide? Yeah. So let's get into a demo and see how this works as well as how to configure.
A demo on how to create reader endpoint to route the connection to different replica using the same endpoint in connection string. Navigate to the replica pane, where you'll see both the primary and replica servers. In this example, the primary server is located in central India, with a geo replica in South India and a local replica in central India. To create a reader endpoint, click Create Reader Endpoint. This will open the Create wizard, where you can proceed with the setup. Choose a unique name for the reader endpoint, which will use the DNS suffix. Reader, MySQL Database, Azure.com. The current routing method is performance, which selects replicas based on minimum latency for read requests. Additional routing options will be introduced in public preview and GA. Routing method defines what logic the reader endpoint should use to select a replica when a read connection request comes in. The DNS TTL determines how long the endpoint sticks to a replica or endpoint before reapplying routing logic when connection request comes in. Now the minimum value in private preview is 30 seconds, and we plan to reduce this to 0 at public preview and GA to allow rotation on every connection request made. The maximum replication lag setting ensures replicas are marked healthy only if their lag is within the defined threshold. Replicas exceeding this limit are excluded from routing. Minimum value you can set is 60 seconds. After completing these configurations, navigate to the resource page. From there, select the replicas you want to include in routing. You can choose all replicas or only specific ones. Additionally, you can enable the Attach New Replicas to this endpoint option, which ensures that any newly created replica is automatically added to the routing set. Once your selections are finalized, click Review, then Create to complete the setup. Deployment will be validated and submitted to Create Reader Endpoint. You can see deployment is in progress. Wait for the deployment to finish. Once the deployment is complete, which typically takes a few minutes, click on Go to Resource and navigate to the replication pane. Here, you'll see the newly created reader endpoint along with its name. Under Settings, you can modify certain configurations. You can add or remove replicas participating in connection routing. Although the routing method is currently fixed, it will become editable when additional options are introduced in public preview and GA. You can change other configuration which are editable. After making changes, click Save and, if needed, use the Delete option to remove the reader endpoint. You can copy the reader endpoint name and use it in your connection strings. Next, let's explore how to leverage this reader endpoint to connect to the replica set and handle read workloads efficiently. This Python script connects to the database and runs a select query to identify the server name it's connected to. Key host in the connection string is set to the reader endpoint, and you specify the remaining properties, such as username, password, and other database parameters, accordingly. In the main function, the script opens a connection using the reader endpoint, queries the server name, prints the result, and then closes the connection. It operates in a loop with a 40-second delay, reconnecting each time to execute the query and display the current server name. Now, let's execute the Python script. As you can see, the first connection was routed to one replica, then switched to another on the next attempt, and continued rotating. Each time a new connection was made, the reader endpoint applied its routing logic to direct the request to different replicas.
I hope now it would have given a clear idea about why we are using the reader endpoint and how this would help to make sure that the applications need not have to worry about the connection routing on which replicas your query will end with, right? And it also gives you an ability to actually route the traffic as well as the resiliency as well, right? Because if one goes down, it's still you are able to connect to that replica. Uh, this is a private preview, and for early access, there is an enrollment page if you would like to participate in the private preview and you want to try for it. As of now, it's free of cost in private preview, though it will be charged post public preview and GA. So if you would like to test it in your environment, you could actually uh, go to this URL. The early access URL is there. I've shared that in the share that below. So you can actually go ahead and use that MySQL early access aka.ms/MySQL early access enroll, and then just fill that form, and then we will enable it for your subscription, and you will be able to do the testing. Now let's move on to the next feature, which is also in private preview. You can also enroll for this feature also if you would like to, in the same URL which we just shared. Now, what does this feature does? It actually helps to rename the server from the current name to another thing. Currently, if you look into it, the name cannot be changed post the provisioning of the server. Now we are trying to take out that limitations because there were a lot of customers asking for it, generally because they wanted to adopt some organizational wide naming standards, and they need to change it after the server has been created, or some cases where they wanted to move from dev to stage to prod, and they want this naming conversions being accommodative, so that they could have a consistent naming across all environments. It also helped in case of promoting replicas, or when you do a peter, because you peter to a different server with a different server name. So without changing the application, without changing the connection strings in the application, if you rename the server to the old name, deleting the other server, you would be able to go ahead and use the same connection string to connect to the database, right? So all these, and also for multi-version upgrade is another scenario or a use case where this can be used, where you could create a replica, do the multi-version upgrade of that particular server, and then rename it to the old server, and then start using it, which will actually make sure the replication. It's very simple. On the overview tab, you will get a rename preview like this, and you could just see that it will show you the old name. You can give a new name and then click on save, which will actually make sure that the new server name is there. And it's a very near downtime, very small downtime, because the DNS refresh has to happen. That's only downtime you would see. Currently it is supported for general purpose and memory optimized or business critical tier at this point of time. Even for this, as I earlier explained, you can actually go to the same URL to enroll, and you can select your subscription. You can share the subscription, and we will enable for those subscriptions that you would be able to enjoy the private preview for rename server, and as well as for the reader endpoint. Now, moving to the next feature, this was also announced in our Ignite, dedicated SLB for HA-enabled servers. Now, what does this mean is, initially when we used to have a failover or a DNS switching from one node to another node in an HA-enabled server, we used to use the DNS switching mechanism. So for the same name, you would actually change the IP address of the server to the new node, and that is how you are able to connect it to the from node 1 to node 2. Like here, if you assume that in this picture, if availability zone 1 is node 1 and availability zone 2 is node 2, if you wanted to fail over from node 1 to node 2, you actually have to use the DNS switch where it actually updates. Now, the disadvantage of this was there was a 30 seconds TTL at Azure level, and at times at the client level also. When you have a TTL for DNS, it needs to pass the TTL so that it forgets the old IP address which it was serving, and it will start connection. So though your server was ready to be connected, the DNS TTL used to actually delay your connections, which actually made the failover time a little greater. So in order to reduce the failover time, we actually changed our infrastructure at the backend to use an SLB, so that the IP address remains the same. And what I would what would it happen is, whenever there is a failover request, using just the MySQL data path is changed in the thing. Initially, it will be connecting using a load balancer rule to server number 1, and whenever the failover happens, that rule actually changes and connects it to the server number 2. So that way, there is no DNS resolution problem, because the client always keeps the same IP addresses which it was using before, and that actually eliminates these delays which was created by DNS TTL. Now, for any new server created, the dedicated SLP feature will make sure that when it is enabled by default on any new provision servers. For all provision servers, you want to do it immediately. You can disable and enable HA, which will take care of it. Or if it is not the case, we are slowly migrating the servers over the period of the next 6-7 months when during the time of maintenance, so that there is no much downtime for the customer to SLP. So going forward, next 6 months, existing servers also will be migrated to the SLB based architecture. But today, if you create a server, it is going to be the server with SLB. So that's the dedicated SLB feature. Can we move on to the next feature? This was another asked feature of lowercase table names, which was a migration blocker for many of the people who are coming from on-prem and other cloud providers, because we previously only used to support the lowercase table name one, right? They wanted actually to support two as well. So for all 8.0 plus versions, we are supported starting values 1 and 2. Now, this is a parameter which you need to set at a provision time. So whenever you provision, when you come to the additional configuration, you get this option to set the value 1 by default. Otherwise, it will be, you could select it to 2. This cannot be changed post the provisioning of the server. That's a limitation of this particular variable as well. And another thing to note here is if you restore a server, you create a replica of the server, this version it will be copied automatically to that server. You will not be able to change it. Only when you provision a new standalone server, that's where you get this option to change the parameter. And that's how the parameter works also. Whenever you create a server, you need to make sure that you select the right lowercase table names, all right? The reason why we went for this parameter, previously we were supporting it privately. Now the customers can and themselves change it as their will when they create a server. This parameter is very important in the case of how you handle table names or the objects within the databases. Like previously, it was supported using support tickets. Now you can just it's a self-serve option which is given to the customers. So that's it from my side on the new Ignite releases. I'll hand it over back to Saurabh and team to take it up forward. Thank you, Saurabh.
Yeah, thank you, Sudheesh. These were great updates that you shared to ensure that your apps are resilient, and exciting news on the two private preview opportunities that are available. So I encourage all our viewers to try and enroll for the private preview. We'd love for you to try it out and give us feedback. We've had several customers reaching out for this to try this already out. So it'll be great for the viewers to also try this out. Next up, we'll cover a new update that we recently announced at Ignite, trigger bindings for Azure Functions general availability. And before I go there, first I'd just like to talk about the landscape today, where enterprises and organizations are building more and more microservices and event-driven applications. And what used to happen is that developers used to write boilerplate code, let's say to integrate MySQL database with Azure Functions in the past. And Azure Functions is a serverless compute service, which is highly scalable. But today, what we are doing is we already used to have an input binding functionality available in our suite, which allowed you to query a MySQL database to fetch data and then process the data for application. We also had output binding, where a function can process data and then place that data back to the MySQL table. So updates and inserts will come here. But now, what we've recently announced is that trigger bindings are now generally available. This uses a change tracking functionality to monitor a MySQL table for changes and trigger a function when a row is either created, updated, enabling you to build highly scalable event-driven applications. And with that, I will like to invite Heena, who's going to be coming up on stage, and she will share an actual demo of how trigger bindings and Azure Functions work together. Uh, Heena, welcome to the webinar.
Hi.
Yes, Heena, please go ahead.
Hi, good day everyone. My name is Heena Gupta. I'm a software developer at Microsoft. I work in the MySQL IDC team, and apart from working on the development of the core features of MySQL, I also work on the integration of MySQL with the Azure ecosystem. Let's have a look at the demo for triggers now. We'll begin by creating a function app. First, we have to choose the hosting plan on which we want to execute our functions. Next, we'll fill in the basic details such as the resource group, the function app name, and we'll choose the language in which we want to interact with the MySQL, that is Node.js, Python, Java, C Sharp, etc. Once the function app is deployed, we have various ways to create the functions, that is using the Azure portal, VS Code desktop, or some other editors or CLI. Firstly, we will be setting the environment variable. We'll be adding the MySQL connection string to the environment variable so that we can connect to the database. Once this is done, we will use VS Code to create a function and deploy it to Azure. We are creating a JavaScript trigger using the templates. The templates will create pre-generated files where the user can do minimal code changes to create the function. All we have to do is update the table name in function.js file on which we want the trigger to be monitored. Next, we will be adding the MySQL connection string in the settings.json file. The index.js file will contain the actual function that is to be executed when any modification happens on the table. Here we are just simply logging the changes. Then we would deploy the function to Azure, select the subscription, select the function app that we just created, and then we would deploy the function to Azure. Once the deployment is completed, we will now check the logs. So we will add the azfunc updated at column on the employee table. These are the current rows which are present in the table. Next, we will insert a row into the table. As you can see, the new row has been inserted, and here we can see the logs of the newly inserted row. Thank you. So that was a short demo and a very basic functionality of logging the changes for the Azure functions. I hope this helped you understand better how the triggers can help you in your day-to-day functions. Thank you. Handing over to Saurabh now.
Yeah, thank you, Heena. That was a great demo. And for our viewers, we also had our partner TCS who had given a demo for trigger bindings and other bindings for Azure Functions earlier in one of our webinars. So feel free to check out this playlist from a few months ago around April, May, where they had given a great demo on this functionality. With that, we'll move on to the next section. I'll now be doing a quick recap of all the other announcements that we had announced at Ignite. We've already covered a bunch of them in our session already. So we saw Sudheesh cover a number of them, around 4 of them, and then we had us speaking a bit about giving an overview of how trigger bindings for Azure Functions works. I'll just switch over to my section where this was an Ignite blog that we had published on the day of Ignite. And here is where you can find out all the details that we talked about today around failover performance with SLP for HA servers, uh, the trigger bindings GA for Azure Functions. There are a couple of them here that I'll just give a quick overview right now. The first one is about enabling AI agents to query Azure Database for MySQL using Azure MCP Server. So uh, with Azure MCP Server now supporting Azure Database for MySQL, you can let AI agents query and manage MySQL data using natural language. And no need to write SQL to do that. You can simply ask questions in natural language, like show me the number of new users signed up last week, group by day, and get instant results. So that's a great functionality that we've released on Azure MCP Server. Do look out for a new blog that we'll be releasing on this feature soon. We'll be posting about it on our social handles as always. Next up is about custom port support, where custom port support is generally available for Azure Database for MySQL, where you can configure a port that fits your network policies or avoids conflicts with legacy apps. Now it works across all network configurations, including private link, just keeping the managed experience seamless. So this was the next update that we had talked about. There are a few others that we already covered in the webinar so far about lowercase table name support and then private preview features at Ignite. So if you go to this blog and you can catch up on all the details that we had shared in this webinar so far, along with the private preview link. And just a quick update is that this blog is available for you to go at aka.ms slash MySQL-Ignite 2025. With that, I'd like to share a few documentation and resources, as always, where you can catch up on all these links if you want to learn about Azure Database for MySQL. And if you have any questions, you can always reach out to us and ask us questions on this email, askAzureDB for MySQL at service.microsoft.com. And here are the links to our YouTube and Twitter channel. And on LinkedIn, you can reach out to us on aka.ms slash Azure MySQL-li. I also wanted to talk about the contributor initiative. So if you have not looked at this initiative so far, please go ahead and do this. It's a great way for you to be recognized for your efforts to contribute to Azure Database for MySQL, help amplify the efforts that we are running, and also collaborate much more closely with engineering to engage and build some artifacts going forward. This is the link for the contributor initiative. You can also earn verified badges, friendly badges for different levels that you achieve. If you want to appear in a future live webinar, you can fill out this form or just give us feedback if you want to suggest any topics going forward. And you can also write to us as always on the same email ID. And with that, I would like to thank you all for tuning in today. This was a special session for us where we talked about Ignite Recap, and we look forward to seeing you again in the next one. Goodbye.